All right, welcome everybody. I'll be starting now. I hope that's fine. Patrick.
Yes, you can go ahead. Then if
All right.
you can turn on your camera for us, we'll appreciate it.
Sorry about that. Okay. So today we'll be discussing DevOps and we'll be focusing on collaboration and feedback. So we'll be focusing on 5 major areas today for this discussion, looking at what is DevOps. We'll also look at how DevOps works. We'll also look at the DevOps lifecycle, the tools associated with DevOps, and then we'll finally close with the benefits of DevOps. So what is DevOps? DevOps is a set of practices, tools, and a cultural philosophy that automates and integrates the process between software development and IT teams. It emphasizes team empowerment, cross-team communication and collaboration, and technology automation. So this simply means that with the regular process of software development, introducing DevOps, you have the advantage of communication and feedback between teams to facilitate and speed up the development process of softwares. So why is DevOps so important that we have to discuss about it today? First off, we have a process that has to do with software development, and various methodologies are out there, but DevOps aims at viewing people as people and viewing a task as an objective that can be concluded by people. So meaning that the people who execute these tasks are considered humans. So factors are, emotions are factored into the development process, and people are given the benefit to air their view, and the process is as open as possible to hear people's feedback on particular process and how to improve upon it. So how does DevOps work? How does DevOps work? A DevOps team includes developers and IT operations working collaboratively throughout the product lifecycle. Just like I stated, you have the development arm of the software development lifecycle, and then you also have the operations arm. So these two teams are two different teams, but DevOps brings them together to work under the same space and to work not siloed, but to work in close proximity with each other, even if it is not under the same building, but they are actually tagged as teams. So these teams work together to achieve a common goal, which is regarded as an objective or a project. So why is DevOps important in this sense? Considering the fact that a task can be given, a project has numerous phases to it, and different changes occur within the process of developing a software. It is important to take into cognizance the fact that change is inevitable, but the process to achieving our said objective shouldn't be one that changes along with times. So should you have a system that works and the system is not broken, you can as well add to the system and not try to change it. And that is basically what DevOps tries to achieve. What can I do? So we'll look at the DevOps lifecycle. So what is the DevOps lifecycle? DevOps lifecycle has to do with the different approaches, the different phases of the DevOps process, the development process of any software or any product, and how they are interrelated to one another. So because of the continuous nature of DevOps, practitioners use the infinite loop to show how the phases of the DevOps lifecycle relates to each other. Despite appearing to flow sequentially, the loop symbolizes the need for constant collaboration and iterative improvement throughout the entire lifecycle, just like I said initially. So the process that precedes any other process is tied to it, in the sense that every step of the way is sequential and everything must be done according to standard and according to scope, because a system has a desired output. Take, for example, I'm supposed to build a particular software, and because of the different frameworks out there, I feel more comfortable using a particular language. That's because I feel comfortable using it, I feel like I can impose it on the system. But that doesn't work because because the system doesn't encourage you to freelance with a different framework. You are tied to the life cycles approach, and whatever methodology is that is proposed, it's adaptable to change, in the sense that when I am developing a software and then take, for example, I come into I stumble upon a bug or something, and then I see that it's an open issue on this particular software, and then the discussion around it seems to be that it has to be done a particular way. So because it has to be done a particular way and my system doesn't encourage it, DevOps allows you to move past that point, in the sense that you look for other alternatives that work with the system and doesn't break the flow. So should you be adding a new feature to an already existing system, you're only aiming to add the feature that has been brought back to your notice because of the feedback that end users have observed and the constant collaboration from team members to improve upon the process. So the DevOps lifecycle has several phases. It has different phases to it. So the first one we'll be looking at is the planning phase. So the planning phase has to do with the planning and coding phase has to do with continuous integration. So continuous integration is a concept where features, bugs, and observations are tackled in time because of constant feedback people get or developers get from the operations team based on the quality of product that has been released. So should there be any change that should be proposed from any point and it is given back as feedback to the development team, they can be able to make those changes and add value to the already existing product. So the building phase, just like I stated, is part of the coding. I said it's the coding phase, but it's part of the building phase. So we make use of Git. Git is an open source version control system. So basically, a version control system acts as a measure to measure changes that happen in a particular pipeline. So I am writing a code, and because of this particular observation that has been brought to my notice, I decide to create a branch, and then I work on that branch. Then because of the fact that I have made the improvement and I want people to review this change, it's not possible for me to, conventionally, it's possible, but with a version control system, it is not possible for such changes to be integrated without approval from the person in charge of managing the code base. So should there be any change that has been proposed and the change has been fixed or the new feature has been developed, it has to go through review, and then it is then integrated to the main branch. So the importance of this is that there is control to how changes are made, and those changes are deliberate because it has been reviewed and it has also been tested to make sure that it doesn't break the current working system that is already out there. So continuous integration and delivery. So CI/CD allows teams release quality products frequently and predictably, from source code repositories to production with automated workflows. Teams can merge code changes frequently, deploy feature flags, and incorporate end-to-end testing. So they mentioned testing. Testing has to do with this change that has been made. We test it and make sure it works. And then we now test it with respect to the existing software and make sure that it doesn't affect what was working in previous times. So there's unit testing, and there are several other tests that can run alongside your pipeline to ensure that this particular change doesn't break the system. So there's monitoring and alerting. So you can quickly identify and resolve issues that impact product uptime, speed, and functionality, automatically notifying your team of changes, high-risk actions, or failures. You can keep services on because of the fact that you are aware of what is happening. Before the end user gets to observe this change, you have observed it and you're already taking action because of the fact that you have monitoring and alerting part of your system. So DevOps allows you to add that to your process flow. And then there's operating. So you manage the end-to-end delivery of IT services to customers. This includes the practice involved in design, implementation, configuration, deployment, and maintenance of all IT infrastructure that supports an organization's service. So should there be a time that comes when you need to make an improvement on a proposed plan, the system is aware of that. Everybody that's on the team is aware of such proposition, and then everybody is carried along with the process of this change, and this change will work in line with the already existing infrastructure. It will work with the already existing configuration and deployment patterns that's already available in the organization. And then there's continuous feedback. So continuous feedback is the most important part of the DevOps lifecycle, in the sense that I have made a change, like I said, and I don't know how this change affects the end user. I don't know what was there before is better than what I am proposing, or what is already being proposed. So because of continuous feedback, I get to know that, okay, this change that I will release in the future, it might not impact the end user the way I am expecting it to impact the end user. I might have an objective in mind as to how I want it to affect the end user. But because of continuous feedback, I can improve upon the process and incorporate my customers' feedback, and also increase and improve the next release cycle. So we look at the DevOps tools. In DevOps, there are several tools that are incorporated into one another. They are integrated into one another to ensure that there is seamless flow from development phase to deployment. And on my screen, you have a lot of them. This is actually from, this is an Atlassian integration workflow. So you have Jira software, you have the Confluence, which serves as the serves as a collaboration and continuous communication tool. You have Bitbucket, and you also have the Jira software also, which also serves as the part of the building phase of the project. Then you have a lot of them out there. Microsoft has its its DevOps lifecycle plan. AWS has their DevOps lifecycle plan, and a lot of them out there are open source for use, and then you can also improve upon them because it's open source, to ensure that, yes, this particular change that has happened, we have a solution for it should there be any change that comes up in the future. So we look at the benefits of DevOps. Teams that practice DevOps release deliverables more frequently with high quality and stability. So take, for example, you have a software, take Microsoft, for example. They have a system that works for them, and they don't reinvent the wheel every time they intend to put out a new release, because the standard of production is already created and it's already high. So you coming into the system, you're only adding value to that system to improve on the standard because of the feedback you've got. And you're able to deliver these changes and releases in record time, and it is still with high quality and stability. You have improved collaboration. The foundation of DevOps is a culture of collaboration between developers and operations team who share responsibilities and combine work. This makes teams more efficient and save time related to work handoffs and code, and creating code that is designed for environments where it runs. So because I have a system that works and everybody is on the team, I make a change, it is evaluated, and I get feedback in record time to make changes that are in line with our objective as a team. And then there is no need for second guessing the process, because the process already works. So what you are doing as a person that practices DevOps, or as a team that practices DevOps, is to improve upon this system and collaborate between one another to ensure that the system is getting better as time goes on. So there's rapid deployment. Because of the fact that you have a system in place, you can deploy rapidly. You can deploy your softwares without any fear of without any fear that the code that is being released might not work on any particular platform. So it has been tested, it has been deployed, and then it has been reviewed also. So because of all of these checks that have been put into place, the room for error has been reduced to zero, close to zero actually, because there's still also room for error. So the system allows you to make releases and make changes that are rapid, and deploy these changes and still not get negative feedback. Or even if you get negative feedback, your negative feedback is measured and controlled, because you have full control of your process flow. And then there's quality and reliability. So practices like continuous integration and continuous delivery ensure changes are functional and safe. So how do these changes work? How do people ensure that all of these things are put into place? You have a process that works, and this process is tied to a pipeline. Your culture, how you guys develop the software, you put it down as documentation, and should there be a revision in the future, those documentations can be revised, and the quality of products that are being released are still up to standard, because yes, the quality of products that is being developed is up to standard, and it's also increasing with performance as time goes on. So monitoring helps teams keep informed of performance in real time. So there's security. Security is a very vital part of any development process. Take, for example, your conventional development process before the advent of cloud computing. It was a process that involved manual uploads from your local machine to cPanel via FTP, or let's say you're using SSH, or you're using any form of transfer protocol. Yes, there's the assurance from my own part that my file is safe. The code I am uploading is safe. But how is it possible that should there be a breach in security, your code goes down because there is no security measure put in place to check that this particular code that has been released is working correctly and it is not a cause for the downtime that has been experienced? So you integrate security to DevOps to get DevSecOps. So integrating security into your pipeline will improve upon the performance of your products. Security is built into products by integrating active security audits and security testing into agile development and DevOps workflows. So we've come to the end of today's presentation, and I would like to take questions. Should there be any out there?
Yeah, thank you very much, Emmanuel, for your presentation. So at this point, if any of us have a question, we could address it to Emmanuel, or if there are no questions, Emmanuel could ask us a few questions just to test our understanding of what he has explained so far. Questions, please.
So I think there are no questions because there are no responses also. All right, so I will ask my question since there are no questions. And I'll be asking, who should I ask? I'll ask it openly to make sure that it is understood by everybody. So what is DevOps? That is just the question I ask. Anybody can answer actually. Mr. Robert Covenant.
Sorry, I didn't get your question.
Oh, your miss is so sorry about that. So what is DevOps? That's the question.
What is?
DevOps.
Sorry, I don't know.
Does anybody have an answer to it? Does anybody want to help Robert out?
Okay, DevOps is a set of practice that combines software development and IT service.
Okay. Okay, that's correct. But to be very clear, DevOps is more than just a set of practices. It's a cultural philosophy. It is a way of life of any organization. So whatever practice you implement to software development, that is from planning phase to the deployment phase. How do you structure your development process, and how do you get your end result? So the whole process is regarded as DevOps. I think that's all from me. Thank you for having me.
Yeah, thank you very much. Okay.